Hello everyone, today we will present our project is designing and implementing a system for managing the cooling device for vaccines. The team members are Phạm Quỳnh Trang, Ngô Ngọc Phúc, Uyên Bá, and Vũ Tuấn Anh Khoa. First, we will go to the contents, included introduction, experiment, result, and conclusion. Now we will introduce our project and the creation. Recently, there are many diseases occurred not only in Vietnam but also all over the world. Because of this, the demand on using, transporting, and using vaccine is becoming more and more vital. In the past, people used a lot of methods such as dry ice or fridges. Take dry ice for example. Dry ice is simply the solid form of CO2 and is very dangerous for people when inhaled. Because of this, we decided to create the cooler box and as the alternative of those methods. Cooler boxes are used to transport vaccines from vaccination centers and hospitals to the remote areas. These boxes ensure vaccines are stored at the required 2 to 8 degrees, and its mobility and durability helps people to overcome the limitations of roads in these areas. Next, we will go to experiment.
As for our method of carrying out this experiment, we have utilized the Peltier effect. These modules prioritize cooling over power generation. We have also replaced the traditional heat sinks with water blocks in order to sufficiently cool the thermoelectric cooling devices, but also removing any air-based limitation the cooling has. This is our outline for the cooling box. So this green little box right here is our cooling box, and this circuit map is our electrical wiring system. The power is first fed through a power supply, which goes through a dimmer in order to control the current, and next is a switch. This is optional, and it basically just turns on or off the entire circuit, and after that it goes through a voltage meter and an ampere meter to measure the current, and finally it goes through these 4 thermoelectric cooling devices in order to cool the cooler box. We also have this water cooling system, which is the water is pushed through water pump through these pipes and finally into these water blocks, so the heat from the thermoelectric cooling device can be dissipated. And finally, we have this big red box outside right here. It's our insulation box to carry everything else inside. So the tools for our experiment we have chosen is a green metal box with the capacity of 512 centimeter volumetric, an insulated box with the capacity of 24 liters. Our Peltier devices with the model number of TEC 12706K10. A power supply so that we can turn an alternating current into a stable direct current, water pipe and water pump in order to supply our water cooler with the water, and our thermal paste in order to increase thermal conductivity between the sides of our thermoelectric cooling devices. We also have water pipe connectors, a thermometer to measure out our temperature inside the cooling box, a multimeter to measure the voltage and the ampere, and the dimmer to control the current.
And now is the process. First and foremost, we check the hot and cold side of the Peltier device. Then we spread the thermal brace on both sides of them. The hot side of the device is attracted to the cool water cooler, and the cold side is pressed against the metal box. Then we make a water pump system to direct water into the water cooler to help reduce the temperature of this device. After that, we make a wire power from the power supply leaded to the dimmer and a multimeter and attach it to the Peltier device. Next, on the outside of the box, we carve out a few space for dimmer, multimeter, thermometer, and block wire. Inside of the box, inside of the last box, we have separated it into two compartments. One is empty and one is containing water. We put the water pump in the water compartment and all the rest of our device on the other side. And finally, we cover all this by a sheet of mica and only leave one hole for that fit with the metal box so we could to see inside. And this is our result. So and next is our data table for experiment results, and we have measured it by a probe that placed in the middle of the box with accuracy 0.5 degrees Celsius, and the data is recorded by over 30 minutes, and we have tried to connecting wire in parallel and in series. So in parallel, after 10 minutes, it can decrease at 17.5 degrees Celsius, and in series is 1.5 degrees Celsius. So you see that in series is more effective than in parallel. And from this table, we can we can draw a graph, so you can see that. So you can clearly see that in series is reduce the temperature faster, and it can hold the low temperature for a long time than in parallel.
And this is a table of temperature management. The temperature observed on the device is the result inside the cooler box, which can be adjusted by changing the current intensity. As you can see, the cooler box achieved 2 degrees at 0.75 amps, which is the temperature to store a variety of vaccines. And when we continue to increase the current intensity to a maximum of 1 amps, it can cool up to negative 0.6 degrees, which is expected to store the vaccine requires special storage temperature. From this table, we conclude that the higher the current intensity is, the lower the temperature we reach. And this is the table of price list. We spend in total $27 creating this product, lower than the average price of other cooler box on the market, which is usually $45. And this is the price to produce one product. If we produce in large quantities, the price will be lower and will be able to compete with other cooler box on the market. And in conclusion, we have achieved the goal of reducing and maintaining the temperature of the cooler box. We also hope to exploit the particular effect in order to create abundance of items which utilize this feature to creating more thermoelectric drying or cooling based commodities. And our team have also discussed to find some solution to develop this product. Firstly, we utilize smaller power to use backup and rechargeable batteries, so we don't have to plug in electrical ally, and we will add some accessories to the cooler box such as wheels, covers, handles to increase its convenience, safety and efficiency. And thank you for following our presentation.